Welcome to the session on Elastic Scale for Azure SQL databases. Thanks for joining me at such a late time during the afternoon. I'm probably the last one standing between you and dinner, so I appreciate you all coming to the session. Hope it's an interesting and worthwhile time for you in the session. I've been looking forward to this session quite a bit. I've, what I think, put together some interesting content and some interesting stuff. And the session has been built by a colleague of mine, Bill Gibson, and myself over the last couple of weeks. Bill is unfortunately not here to join us, so it will just be myself presenting. And both Bill and I had a lot of fun putting this together. The overarching topic is everything around Elastic databases. And what I want to show to you is basically how you can think of using all these new Elastic database features that we have been talking about since they were announced last week in the context of a pretty realistic application. And the particular application scenario that we have chosen for that is a SaaS application, a software as a service application, where you basically, as the SaaS provider, are allowing your customers, your tenants, to sell tickets with a somewhat customized experience. You can think about basically the Met having its own stack for selling tickets. It can be the San Francisco Opera, but also other things like jazz clubs and little theaters, all the way down to judo studios. So I'll walk you through all of that throughout the session. A little bit about myself. My name is Thorsten Grabs. I'm a program manager on the Azure SQL database team, and I've been working on SQL Server, the SQL Server product and the SQL Server services for about 10 years now in Redmond. And it is interesting to see what has happened throughout all that time. I started out working on the query optimizer for the Box product when we were still shipping shrink-wrapped software. And now a lot of that is, all the innovation is at least happening first in the cloud for us. Certainly a very interesting journey for myself. Now, the kind of, to set some context, the topics that I want to cover is, I want to first give you a little, very brief introduction to Azure SQL database, just to provide a basis for everybody so that we know what we're talking about. Then I want to talk a little bit about what are the typical characteristics and patterns that we see when SaaS applications are using SQL database and characterize that. And then once we understand the space, talk a little bit about how the Elastic database capabilities that we have been announcing last week, how they make developing these kind of applications on top of SQL database much easier, and how they also make it easier to manage these applications. In particular, when you have lots of databases for an application. And that's typically very easy to end up with if you're a SaaS application provider. And I'll explain why. The other interesting aspect that we're going to run into when we discuss the characteristics of SaaS applications is how do these workloads behave and how can you accommodate these workloads in an easy way from a manageability perspective, but also from a cost perspective. So then let's get started with just setting some context around Azure SQL database. The key thing to keep in mind, it's a fully managed cloud service for databases. And the key objective for us is to provide as much out of the box through the service offerings so that you can focus really on your application, on your business logic as much as possible. And historically, we have focused a lot on enterprise applications. Initially for the cloud service. However, the picture is getting a little bit more complex. We are starting to get very excited about the opportunity for SaaS applications as well. And that's one of the key motivators for us to start working on all these Elastic database capabilities. And historically, the enterprise space has been very interested in workloads that have fairly predictable performance needs and resource needs. So we've been catering to that for quite a bit. And that has led to a certain pricing model that I'll explain briefly when we get to it. Now, the new piece that's emerging with SaaS applications and data tiers for SaaS applications is that the database workload for individual databases in a SaaS application is no longer that easily predictable as it used to be for regular enterprise applications. And that makes it harder to manage it through the feature set that we used to have, at least up to until last week. And how it gets easier, I'll explain that as well. Some of the key takeaways around the service, once you will basically buy a database from Azure SQL DB from our service, out of the box you get 4 nines of availability, and behind the scenes we're automatically taking care of taking copies, replicas of the data, managing that for you as part of the service, so you get that out of the box. In addition to that, you can also opt into our geo-replication, geo-disaster recovery capabilities, which makes it very, very easy, for instance, to stand up replicas in a different data center, in a different geography for disaster recovery purposes. All of that is very easy, and that's one of the benefits of having a managed cloud service doing it for you. We pay a lot of attention to security and compliance, and over the last year, we have made significant updates to the surface area of the database in the service, so that we're pretty much at par in terms of capabilities for functionality that you can do on-premise within the context of a database, and what you can now do in a database in SQL DB in the cloud. And I specifically mentioned within a database, there are certain levels. So a database on-premise lives in a server in an instance, and there are manageability concepts that tie back to the instance, to the server. Those do not necessarily map directly one-to-one to concepts in the cloud. But if you are within a database itself, all the functionality you have there will map one-to-one to what you get in a database in Azure SQL DB. So how would you get to a database in our service? There are basically 3 different performance tiers that we offer, starting with basic. It's targeting light workloads. You can then continue into the standard tier with a couple of options in there. And we think it's suitable for most of the business applications that are out there that need a database. And then the premium tier is for databases that have high resource and high performance requirements. Now, those are the differences between these different tiers. What's probably more important is what's the same across all of these different tiers. We are trying to provide the same surface area, the same functionality, the same feature set across all of these different service tiers to the extent possible. There are certain nuances where some of the capabilities have higher resource demands. That makes it difficult to offer them, for instance, in the basic tier, but then you would get them in standard and premium. And our goal is to work on all of the features so that they are eventually available across all of these 3 different tiers. The second aspect that is consistently the same across all of the tiers is the availability. As I mentioned, you get 4 nines of availability out of the box. That's our SLA, and that's not different between the service tiers. And for the remainder of the session, we're going to dedicate a lot of time to the workload elasticity part, so I'll not explain too much on this slide here. But again, the capabilities in that dimension are, again, aligned across all the different tiers. So let's jump into the application that I mentioned that was a lot of fun to work on over the last couple of weeks. And to do that, let me switch over. Actually, no, I think I'm on 8. Let me switch over, and here I'm in the browser. Let me maximize this. And here I'm on a web page, and the web page is basically shown through the web tier of the application that we're working with. It ties back to a dedicated database that's dedicated to all the transactions, all the orders, all the ticket sales for this particular tenant or this particular customer. So this customer is Contoso Concert Hall, and it's a more or less working application. So I can sign in with my name here and my password. It recognizes me, so welcome back, Torsten. I can see, oh, there are various events happening in the next couple of days. Why don't I go in there and buy tickets? And here's a seat map, and then I can go into purchase tickets. and it will ask me for my credit card information, for my name, and so on. And if I hit purchase, then this will show up in database tables that are basically running behind the scenes. And I'll explain the stack for it in just a second. So this is Contoso Concert Hall. Let me show you one more aspect that I find interesting. So look at this URL up here. So Contoso Concert Hall is basically rendered through a specific URL that's dedicated just to Contoso Concert Hall. And I took a very easy approach here. I basically provisioned that URL just through Traffic Manager. So you can definitely get more sophisticated than that through DNS and whatsoever. Let's jump into a different tab. And let's start in the same place again. And look at the URL. Again, it's a Traffic Manager URL, but this is for Fabricam Jazz Club. Also, notice that there's some customization that has been happening, so it's a different picture. Also, the events that are happening are different. So that's the second tenant, example tenant that I have. And that tenant, as it happens, gets its own database in Azure SQL DB, so that the data for this tenant for Fabricam Jazz Club is completely isolated from the data for Contoso Concert Hall that we just saw. And there are a couple of additional benefits of keeping all this, the different tenants in different databases that I'll speak about in just a minute. And just for the sake of the example, here's a third tenant, the Dogwood Dojo site that just follows exactly the same pattern, has its own events. You can go into tickets and buy tickets for the competitions that are happening in that judo club. Okay, so that is a quick overview of the application that we're going to use. And as I mentioned, I see this as an example of a typical software as a service application in the cloud. And there are a couple of interesting just concepts that I want to introduce you in terms of terminology. So the obvious one is the SaaS provider. And for the context of this session, you can think of me as being the SaaS provider that is implementing and managing and building that SaaS application. That SaaS provider then has different customers, different tenants. The Contoso Concert Hall was one, the Fabricam Jazz Club another one, and we saw the Dogwood Dojo as the third example of that. Those are the customers, those are the tenants, and they in turn have end users that log into their sites through the web experience that we just explored. There are a couple of properties that these tenants, the customers of the SaaS provider, are interested in. One is how can I make sure that the data for me being tenant 1 is separate from the data that is being kept for tenant 2? How can we establish data isolation, privacy, and how can we protect it? So that's a concern that's probably top of mind for many of the customers. The other aspect that is very important for the SaaS provider is being prepared for a situation where my SaaS application ideally becomes viral at some point, or at least the business grows substantially over time. So how can I, as easily as possible, add additional tenants, add additional customers as time goes by? That's the second aspect. The third aspect that we will see is quite common, quite typical for these kind of scenarios is that the usage of an individual tenant, of an individual customer, is quite unpredictable. So for instance, if at one day in, let's say, Madonna has an unplugged session in one of the smaller clubs in town, and this club happens to sell tickets through our SaaS application here, I bet you there will be a lot of traffic for that site when that happens. So being prepared for these situations where you have to accommodate sudden bursts, sudden spikes in terms of capacity and resource needs, that's another very common characteristic that we see for these SaaS applications. Okay. So with that, let's talk a little bit about one of the underlying principles that I've used to implement the data tier for that SaaS application, and where a lot of the properties and capabilities that SQL DB provides make it much, much easier for me to build these kind of applications. So the principle that I use, and I've mentioned it a few times already, is each customer, each tenant gets its own database. So when I created Contoso Concert Hall. I basically created a database, made it available to the application, and then made sure that whoever hits that Contoso Concert Hall URL is being routed into that database when they wanted to run requests, process tickets, and so on. Keeping separate databases for separate customers has a couple of advantages. So the database provides a great container for us to work with. We can secure it separately, so we can provision different credentials, users, logins. We can audit it separately. We can monitor it separately out of the box through experiences that we have in Azure SQL DB. We can manage its capacity separately. Also, recovery becomes much more straightforward. If, for instance, one of the tenants goofed up and deleted a bunch of ticket orders in the system, and you have a mishap like that, it's very easy to restore the database back to a particular point in time to basically roll back that mistake. Those are some of the motivating factors that led us into a place where we want to have separate databases for each individual customer. Question, yes, please. How do you restore back in time? You can do that through just a regular management surface for SQL DB. You can say, hey, here's a database. I want to recover that database to a particular point in time. And you can go through that wizard, and it will do it for you. So depending on what service tier you pick, we basically keep backups up to 35 days. And you can restore to any point in time along that timeline. Now, having made this kind of design decision to keep separate customers in separate databases, there are a couple of challenges that arise as part of that. So the first one is, for instance, if I have these many databases, how do I manage these databases? How can I query across them? How can I make changes to the schema and roll that out across all of these databases? We'll talk about a number of features that help you with exactly these aspects. In addition to that, I want to retain, obviously, my familiar programming experiences if I'm using ADO.NET and the SQL client libraries. I want to keep doing that as much as possible. And then Visual Studio integration, Azure Portal, all of that remains equally important. So we'll take a look at all of that. So with that kind of exploration of the actual application and a quick summary of the requirements that we had on the last slide, let's dive a little bit into the architecture. And it's pretty straightforward. Starting with the bottom, at the bottom here, we have the individual customer databases from customer 1 to customer n. It's easy to scale out by just, as I mentioned, adding an additional database into the mix if I want to add an additional tenant. On top of that is a cloud service with web and worker roles that is implementing the experience that we just explored through the browser in the demo that I gave. And that is scalable. It can be load balanced, or I can use Azure Autoscale to scale that cloud service in a policy-driven fashion. In addition to that, we have this little catalog database sitting here. And that's basically the place where I keep track of what are the tenants and how is a tenant mapped to a particular database down in the data tier. And why is that important? It is important to address kind of the first challenge that you will run into, which is data-dependent routing. So imagine me coming to the Contoso Concert Hall URL. How do I find out and how do I get into the right database for that particular customer or tenant? And to illustrate this problem, so basically here is the end user connecting to the cloud service through that URL. Then the next step for us is to basically go and look in the catalog, what's the database that we have assigned to this customer to that URL, and then we need to open a connection into that database from the cloud service. Obviously, you will easily spot that this catalog can become a bottleneck if you have lots of traffic on your cloud service. So we'll talk about how we can avoid that becoming a bottleneck in just a second. So in order to address this problem, already a while ago, we started introducing capabilities that we back then called Elastic Scale, and we have somewhat rebranded them under the Elastic Database umbrella as Elastic Database Tools. What comes with that is a set of libraries and classes that help you manage the data tier of your application, to reason about the group of databases that you have there, and to map tenants or customers to individual databases in your data tier. And these libraries basically give you APIs where you can say, oh, okay, here's that group of databases, let me define it, and here's an ID of a tenant, and here's how it is mapped to a particular database in that group that I have just defined. And this is backed up by a database. So behind these APIs is a database, the catalog database that you saw on the previous slide. And we're using these, the metadata that you're giving us about the group of databases and the mapping of tenants to databases to implement the second capability here, which is data-dependent routing. And data-dependent routing helps you tackle this problem. In comes a request with a particular tenant ID. Let me open a connection into the right database for you. Doing this efficiently, this is exactly the purpose of the libraries when it comes to data-dependent routing. And it builds on top of the multi-database management aspect, which is the first capability here that's provided through the libraries. We have taken great care to implement a very efficient caching scheme that basically takes the mapping information from the database once you have accessed it once and keeps it in main memory in the cloud service. And we have a cache consistency mechanism that will detect when it's no longer valid, but it will stay in main memory, and it will avoid any additional round trips into the catalog database until something changes. So that's really the key point that makes the whole kind of catalog infrastructure that we looked at, makes that lookup efficient and scalable so that it doesn't become a bottleneck. We announced general availability of these libraries last week at Build, so they're basically now a fully supported Microsoft product. They have been in preview for the last half year. They're very easily accessible from NuGet. You can just I'll illustrate that in Visual Studio in just a second. All right, so having said all this, let's see these libraries in action. Switch over into PowerShell first. So here, what I want to show you, what I want to walk you through is basically the whole experience for adding and provisioning a new tenant, a new customer for that application that we just worked with. And let me clear out the stuff down here. There we are. And I'll explain the steps as I walk through them. So the new customer that we want to provision, let's call it Demo Concert Hall. So that's this guy here. We know the Azure SQL DB server where all of our customer databases are stored. This is a different server where we keep the database for our catalog. This is the actual endpoint of the cloud service that we are running. And this is a resource group name that we are using. Let's get a couple of settings in place, including credentials to talk to the databases. Okay. So then the first step is creating an actual database in SQL DB for that new tenant. And that's going to take a couple of seconds. And so the database is again called Demo Concert Hall. And you can see here that we're waiting for that to complete. Let's take a quick look at the other steps that we're taking next until this completes. So the obvious next step is I have created an empty database. It has no relation to the data tier of the application, the overall application. So one of the next steps for us is to register it in the catalog as a database of that data tier. And that's what's happening here in this add shard call. All of these calls are just PowerShell commandlets or PowerShell scripts that I've put together. Some of them are just directly then behind the scenes calling the PowerShell commandlets for Azure SQL database, or they're calling into the Elastic Scale libraries that we just spoke about to do the multi-database management. And you can do that easily through PowerShell.net integration, and that's what I've done too. So here's our new database, just got provisioned. And we already pushed down a couple of tables into that database so that it has the correct schema. Let's add it to the catalog as well through this call here. That should complete a little bit more quickly. And once we have registered the database in the catalog, then we will push out some data to populate it a little bit. That's this set of commandlets or scripts that we are invoking here. And then after that, the last step is obviously provisioning a URL in Traffic Manager for that new customer. And that's what's happening here, creating a new Traffic Manager profile, and then registering an actual endpoint behind the scenes for that Traffic Manager profile. Here's the domain name for it. Let me go and grab that and copy that. So while we're waiting for all of this to provision, let's jump over into Visual Studio. And here I am in the Visual Studio SQL Server Object Explorer. The first step, and you see the set of databases that I have registered here. So I have 30-something databases already participating in the data tier for my application. Let's refresh that and see whether our demo database is already showing up. Yes, here it is, demo concert hall, this guy. And the next step that I want to take is all the databases, all this looks good. Let's attach a debugger to the running instance of the cloud service that's running over in Azure and set a breakpoint in the place where the data-dependent routing is happening for us through the Elastic-Scale client libraries. Let's see whether that works. It should have worked. So there we are. You see the breakpoint. The breakpoint should be active. Remember, we copied that URL that lives in Traffic Manager. Let's create a new tab. Let's paste that URL into it, and let's hit it. And there we go. So we're hitting our breakpoint in the cloud service. Now let's talk a little bit about what you see happening at this breakpoint. So you see that I have a namespace here that's called Software as a Service Sharding. On that namespace, I have a static method that returns me a singleton to what's called a shard map. The shard map is the piece or the class, essentially, that captures all the information about the databases that are participating in my data tier. And the shard map also captures the mapping of tenant IDs to, or customer IDs to the underlying corresponding databases. And that's really the crucial key piece of information that I need to orchestrate data-dependent routing and to broker connections into the right underlying databases. And that's exactly what's happening here. So off of that shard map, I get a call that's called open connection for key, and I can feed a tenant ID into that call, and out comes an open SQL connection that I can then use to just do regular SQL stuff on top of it. Let's hover over this, and it's probably too small to see this, but you can see this has been populated with a tenant ID and actual value, and that's just a function of the URL. So we're parsing the URL as it comes in. We're pumping that into a hash function. The hash function spits out that integer value, and then off of that integer value, we can do the data-dependent routing call. The additional parameters to that call are just regular SQL Server credentials. And then as we scroll down, you can see that the call returns a SQL Server connection, and the rest is just regular SQL client API calls, so SQL commands, SQL data readers, and so on. So the only change for an existing application that you already have is really the change around you no longer invoke the constructor to the SQL connection, and you do not necessarily need to call connection open because this data-dependent routing call already opens the connection for you. So let's hit F5. And I hope I didn't wait too long. No, it still works, so it didn't hit a timeout. And here is basically a pre-canned experience for demo concert hall that we set up, ready to get customized by this tenant, by this customer, and get populated with concerts and ticket information. All right. Good. Let me detach my debugger here, and then jump back. So this give you a sense of what needs to be done in order to scale out that application, to add a new customer into the mix. Couple of simple steps: create a new database, register that new database in our Elastic-Scale libraries for multi-database management, define the mapping of tenants to that database, and then do usual SQL stuff like populate it with a schema, populate it with initial data. And then when you're using our libraries, there's nothing else to do. Notice that I didn't have to rebuild the application. Everything, no redeployment. I didn't have to publish to Azure again. Everything just worked out of the box, which is pretty cool. All right, let's continue on. The next challenge that I want to talk about is what I already mentioned with basically the different performance levels that we offer for databases in SQLDB and how they help you address different performance, resource, and capacity needs for different tenants or different customers. So imagine a situation where basically you have varying or very different loads that are imposed onto your cloud service for different customers through different URLs. How would you accommodate that? And the way how we think about it, or at least one option that you have, is if that is a consistent load pattern that you observe for that customer, is to provision the database with the right DTU amount. And a DTU is a database throughput unit. That's the measure of resources and capacity that we attach to a database. And that's basically also then implying the price that you pay for an individual database. And it's an abstraction over 4 different dimensions. And these 4 different dimensions are the amount of compute that I get on my database, the amount of memory that I get on the database, and then the amount of reads and writes. So if I start out with a very small database that basically stretches just 10 units in each direction, that's a database that has 10 DTUs. And the maximum dimension is what governs the overall DTU amount that a database consumes. So if this database needs more memory, then I want to provision a database that has 20 DTUs for it, although it has much fewer writes, reads, and compute needs. Same, obviously, if you stretch in other dimensions. Now, if I need something bigger, obviously I can go and grow in all 4 dimensions. If I'm a little bit off to the side, again, it's the maximum in any of these 4 dimensions that counts. So that's how we basically measure database capacity. It's a function of the DTUs. The DTUs gives us also a good way to abstract from the underlying physical hardware. As we are basically phasing in new hardware generations one after the other, we want to keep the DTU experience constant for you no matter what physical hardware you run on. Basically, if you then want to provide these predictable performance levels for your customers in the SaaS application, the choice that you're facing is, do I pick basic, standard, or premium for the database for a given customer? And where do I basically position that customer on that range? You can start basic. You can pick anything out of the standard range or go up to a premium 3 database. And you can do that dynamically. So if you start with a certain tenant small, you can go into the system, let's say somewhere in the low standard range. And as the resource and capacity needs for that tenant keep increasing, you bump up the DTU count for the database over time. And that's an online operation. So your database stays available while you're doing that. So no outages for your application. That is very neat because you get hourly billing. So basically, in a very short time frame, you can do these adjustments. And these adjustments are typically quick but not instantaneous because sometimes they involve data movement from one physical server to another physical server. So be prepared for that. If you have a very large database, it may take a few hours for that to actually complete. And these operations are available through a number of different APIs. You can do that through the portal, the Azure portal. You can do that through PowerShell and through REST APIs, or for most of them through T-SQL as well. Here's a quick view into the price card. You can see that in the portal as well. Here are the different options, and it basically starts with $5 for a basic database per month. Here are some examples around how I can do that to other means than through the portal. PowerShell, T-SQL, REST. I don't want to walk through all of them. Down there is a link if you want to read up on these various different options. Go grab the slides after this session and just check out that URL. But the key message here really is you have options if you want to automate any of that or if you want to script any of that, you can easily do that. So you're not necessarily stuck with just a UI. So based on that, we basically have these options. The first database here receives about a medium traffic, so we can place that somewhere in the standard range. The second customer here is getting much more load, so that might be a potential candidate to put into the premium bucket, while others stay in smaller standard or even basic. So that is a great way to control capacity for the individual databases if the number of databases that you have in your data tier is small. So I can imagine doing that for tens of databases, but as soon as you get into the higher tens or you have 100 databases, just keeping track of all of them and dynamically adjusting these performance tiers is quite cumbersome. There was a question in the back. So we'll talk about that in just a second. What you would do with what I just walked you through is essentially you provision for peak capacity, and whatever you think is the peak capacity that you need, that basically governs the service tier that you pick for an individual database. That has a downside if your workload is very volatile and fluctuates a lot between spikes and idle times. Then you are over-provisioning greatly, and then you're paying for resources that you're not using most of the time. And that's exactly the problem we're going to get into. So that's one aspect that motivates what we call elastic database pools. Unpredictable performance or changing performance over time is the first aspect. The other one is the one that I was just talking about. If you have many of these databases, just the manageability overhead of keeping track of all of them, trawling the telemetry for them, and doing the adjustments dynamically is quite an effort. So in order to address this, so first let's think about the challenge here. So you have these lots of databases. Obviously, the data-dependent routing that you saw in the last demo, that will just work happily for you. Nothing to worry about there. But managing the scale factor on each database is no longer tenable. The capability that helps there, and that's the one that we just announced last week, is the elastic database capability that allows you to define a pool, and you attach the amount of capacity or resources to the overall pool, and then you put individual databases in the pool, and they share the resources of the overall pool. What we've announced and what's working today is pooling for databases in the standard performance tier. We are still working on supporting pools for basic and premium for the premium tier. So those are going to come up. It's work in progress. We are still in preview. Obviously, that's going to be available before we GA the pool concept. Now, one of the interesting aspects is when you define a pool and you put individual databases in it, they can now fluctuate in terms of their resource and capacity between any of these standard tier additions. So if a database at some point needs to spike up to the S3 level, the highest in the standard range, it can do that, and it will do that automatically if I put it into a pool. I don't have to do any manageability or operation in order to make that happen. The pool does it automatically for you behind the scenes. So that's the key aspect here on the databases that can burst. That's really helping a lot because that takes the burden away of managing individual databases. If Databases do not fit the pool model, and we can talk about what are some of the key characteristics for that. I can easily remove them from a pool and just keep managing them on the side. That works. And that, again, is an online operation, like changing the performance tier on a database is an online operation. So let's walk through a little illustration of the concept here. So the first key concept is the ability for databases to burst up, to spike to the maximum resource or capacity level within the tier. So this is 100 DTUs for an individual database for a standard pool. And then the second aspect is now I can start packing databases into a pool and have many of them. And this works great if most of the databases are idle, not used most of the time, and they just occasionally spike. Right now, there are 4 different capacity levels at which pools are available, at 200 DTUs, 400, 800, and 1200 DTUs, and we're going to open up that range over time. So that's another area with work going on. With that, what I can do is I can basically group databases into different pools. I may start out with a set of databases in a standard pool for my kind of regular tier customers of the SaaS application. Once we introduce a premium pool, I may create a second pool here for my premium customers or gold customers that pay more, and I may continue to manage some of the databases outside the pool because they need special treatment. All of that helps me now to basically make management of the databases easier, and I'll also save some money, and I'll illustrate this in the portal in a demo in just a second. So let me see. Go over here. Switch over. So here we are. I'm logged into the Azure portal, and here is here's a server that I have. It has a bunch of databases in it. All of them are in the standard tier. And you can see there, Contoso Concert Hall should sound familiar. That's the database it's used for one of the tenants that we just explored. Now I can go into the add pool experience for that server that happens to live in our South Central data center. The first question that I need to answer for defining a pool on that server is, what are the databases that I want to add into the pool? And that actually can be non-trivial. And in order to do that, we are helping you or trying to help you by analyzing the utilization of the databases over time and then making recommendations for you through machine learning. And you see these recommendations here in the rightmost column that says recommended. And it just happens so that all of the databases that I have in this pool are being recommended. And let's go with that. So that's taking care of the first question that you need to answer. And you can obviously adjust the set of databases that you bring into the pool. So I could have unselected a few if I had wanted to. The second question then is, what's the overall resource and capacity configuration that I want to throw at this pool? And that's this tab here, where the first question is basically, what's the overall DTU allocation that I want to set aside for this pool? And that really hinges on the question, what's the aggregate utilization of all of the databases that I have selected in the previous blade over time, and what are the spikes that I see in the aggregate utilization? And you see that in this chart, the aggregate utilization actually stays well below the 200 DTUs, which is that constant line. You also see that all the storage that's being consumed by these databases is well below the 200 gigabytes, which is the second limiting factor on the pool capacity here. I can adjust this, so I can go up to 400 and 800. Let's stick to 200 here. And then the next aspect is really defining the ability of individual databases to spike and to retain a minimum set of predefined capacity. So those are the two settings here, the DTU max and the DTU min. So the DTU max you would set in a way that all the spikes of all the databases are typically accommodated. There are certain cases where you can go lower than that, but let's not venture into those here. The other one is the minimum capacity. If you set aside, let's say, 10 DTUs as a minimum capacity for each database, that would mean that if some of the databases turn out to be noisy neighbors, each database would have at least 10 DTUs guaranteed in terms of resources that it can work with. So if I select this, now we can take a look into the price for that configuration. And that's roughly $500, depending on what you configured in terms of the individual performance tiers for the individual databases. What we expect to see if the workload patterns fits is in the order of about 50% cost savings for that. Right now, this is probably even more because we are preview price, so you get another 50% off. So you're probably at a quarter of the price. Okay. So if I had hit OK, it would have created a pool that looks like this. This is an actual pool, the actual pool that is running under the application. And it may take some time to create the pool because, as I mentioned, some of the databases may be moved around between physical infrastructure. Once I've defined the pool and the capacity allocation for the pool, I can go into the pool and monitor it, see how I'm progressing towards the capacity boundaries, the capacity configuration that I've defined. And that's basically this chart here. Based on that, if I see that either my DTU percentage or my storage percentage is getting close to the capacity limits of the pool, I can go back into configure pool, which is the same experience that we just walked through. So I can go to a different DTU level if I wanted to. So I can change this at any point in time as needed. Okay. So that now basically puts us, question in the back. Yes, please.
What's the availability impact of databases while you're creating the pool?
So while you're creating the pool, the databases stay online. And if we need to move one or several of these databases from one physical place to another physical place, we're doing that work basically in parallel, independent of each other, up to a point where we basically have two independent databases running completely separately from each other. In two different places. Once they're both caught up to the same level, we just flip the connection string from one place to another place. So you're going to see a connection fail, and then you just retry right away. And typically, you would use transient fault handling libraries for that. And then you would get the connection successfully routed into the new place. And this works seamlessly through the open connection for key call, the place where we broke in the debugger. If you wrap that in a transient fault handling block, this will just work. You will not notice it. You will just retry the connection. Okay, so this is where we are. We have configured all of our pools. We're happily running one or even several pools. We're getting much easier manageability, and we're also benefiting from lower cost. Now, what happens if one of those customers is suddenly turning out to be very, very busy? What we can then obviously do is we can take a database out of the pool. We can grow it up to the premium tier, even at P3 if needed, on the side. The connection routing will still work. Nothing of that changes. The connection string stays the same. We don't have to muck around in the shard map. We just adjust the performance level for it. We let it run as long as the larger capacity is needed. Then we can shrink it back again and put it back into the pool. And all of those are, as I mentioned, online operations. With transient fault handling, you will just get rerouted into a new place if anything happens. All right, so that was one challenge. The next challenge that I want to throw out there is now we have these tons of databases sitting around in pools or even on the side of pools. What happens if I want to run a query that stretches across all of them? And there are various scenarios where you could end up with that. So for instance, You want to run a report that gathers statistics across all of the customers or tenants that you have sitting in your data tier. Some of the pricing for your SaaS application may depend on it. For instance, how many tickets did different customers sell through your application, and based on that, you may take a percentage of that. Other than that, there are manageability scenarios. For instance, you want to connect from SSMS into a single place, but then see what's happening on a set of databases that I have in my pool or in my data tier. The usual way how I might think about doing that is I go into PowerShell, I write it for each loop, and then iterate over my databases, run a SQL statement on each of the databases, and then bring the results back together. Obviously, that's very cumbersome. You constantly have to keep track of what's the set of databases that I'm working with, and you're basically juggling these different connection strings yourself. We want to make this easier, and the way that we think about doing that is by what we call elastic database queries that allows you to run a single T-SQL query across a set of databases. And the way that you do this is that you go into a SQLDB database that has elastic query enabled, and in order to get into that database, you just use a regular SQL connection string. You have a couple of simple DDL statements to set up elastic database query, and I'll show you those statements in a minute in the demo. And once you have done that, by running that DDL, that database knows about the other 30 databases in your data tier, and you can define what we call external tables that are views over data that is stored and distributed across all of the other databases in your data tier. And you can then transparently access all of that data through that view, through that external table. That lights up a number of interesting experiences. So for instance, if you're a programmer and you just want to run queries through Entity Framework across many databases, you can go into that elastic query database and connect to it through EF, and then just run a link statement against these tables that are defined over there, and get the results back. Other tools will work as well. So if you're connecting from Power BI or from Excel through the SQL integration, you point Power BI or Excel to that database, that single database that has elastic query enabled, and by virtue of doing that, you get access to all of the other databases in the data tier. The key use case for that, obviously, is interactive querying, lightweight reporting over that set of databases. So let's take a quick look at that in the application. So here, back to Visual Studio. Oops. And let's first highlight this. So here I'm connected to, I'm connected to a database that's called Elastic Query that lives on the catalog server, on the catalog database. And what I've done on that database is I've run the T-SQL to define these external views that know about the underlying tables in the rest of the data tier. And the way that I do that is by first defining in what we call an external data source. And this external data source, the parameters for that are pointing to the shard map that we have been using to define the set of databases that participate in the data tier. And that was the thing that we used to implement the data-dependent routing. If you remember the place where we set the breakpoint in the debugger, that basically was occurring into the shard map that had the information to broker connections into the right database for us. This is the place where all of the information about my databases in the data tier lives. And this is also being used here to implement the Elastic database query. So if you add a new database into your data tier and you add it to the shard map, Elastic queries, as soon as you've done the addition, will start including that additional database into their queries as soon as you have done that. So that basically gives you a single point of manageability, a single point that you need to worry about to define the data tier for your application. And that's reflected through this, oops, no. I'm not in Management Studio. different shortcut. So now I've pre-created this external data source here for this application. The next step, once you have defined these external data sources, is to define these external tables, the views over the underlying data. And if we looked into the underlying databases, we would see a table that has customer configuration with customer name and additional information in it. And here I've defined an external table for it that ties back to the external data source that we had just defined. And that gives us a view across all of the customer configuration tables in the rest of the data tier. And I've done the same for an external table country. And that ties also, again, back to that data source, the external data source that we had defined. And there they are, the two. And now I can do things like this. Run a simple query that groups by theme over the table customer configuration. And I can get a sense of what are the kind of favorite topics that are being covered by the different tenants or customers that I have. So I see, for instance, that jazz seems to be a very popular theme. And theater is the other one. We have a couple of customers in the symphony business as well. And that's a query that we ran, and that stretched across 30-plus databases in the background. Here's another one, basically getting information about what countries these customers are in, and you can see that most of the, or all of them are right now in the United States. Yes?
Is there any data in the Elastic Query database, or is it just the schema definition?
So let me repeat the question for the folks, for the video and the recording. So is there any data in the Elastic Query database besides the metadata, the table definition? Right now there is not. I just have the table definitions in there. But it's a regular database, so you can actually put whatever kind of reference data you might want to keep in a global place. You can put it there, and you can use it from queries as well. So you can write queries that join the external tables with local tables where the data is actually physically kept on the Elastic Query database as well. And that's a neat scenario if you have these kind of reference data requirements. Then you need to only maintain the reference data in one single place. Yes?
Did you change your query with distinct count in there, or is that a no-go?
Say that again?
You use distinct.
Let's see what we want to do. We could do distinct star, but let's do distinct customer name. Or do you want to try this? No, that doesn't work. I'm not sure what kind of query you have in mind.
Well, could we give different, let's say you have different countries or
Yeah.
themes? I want to know how the individual themes for each individual database. I don't want to dump them all out.
Oh, so you want to get the database information into the picture as well.
No, the data. So there'll be like, theme can be red, blue, green, and then green, blue, orange for different tenants, right? So there'll be count four.
So you want to do a select star from customer configuration. Let's do this. And there you have everything. Right? And you could do a select distinct. Let's see whether that works. Event type. And those are the distinct event types that you have in a database. And this query goes across 30-something databases right now. Yeah. Yes?
Do we know what data comes from one database?
There's a different extensibility hook that allows you to include that into your query as well. Let's talk about this after the session. For those folks that are interested in that, I don't want to get into it right now. I can show you how that would work. It's basically a stored procedure call that you can make, and you provide the query that you want to run on each database as part of the stored procedure call, and then you can include the database name into it. Yes? Yes, you can use SSMS for this query, and I don't have an SSMS installation on that laptop. I'm just using SSDT from Visual Studio, but you could use SSMS, and I've actually used SSMS quite a bit when developing this. Yeah, it works. Totally works. And actually, using SSMS is great. Let's say you have a DBA that has a responsibility over the data tier and all the databases in the data tier. SSMS gives you, through these external tables on top of your external query database, gives you a single point of manageability where basically your DBA can connect into that database and from there then query all of the other databases through a single endpoint. So it also helps with manageability, not just reporting. Yes? Good question. Let's look at the execution plan for this guy here. And all of these execution plans will be somewhat similar. You see a remote scan operation as part of the execution plan here. And this is really the piece of the query plan that is then shipped off to the individual databases and is being processed in parallel on all of the individual databases. And the rest of the query plan is basically the residual calculation that needs to happen on the head node on the database that you are connected to. And then there are different variants of this. For instance, if you do, let's say, a join between 3 of these external tables, one case is that you see 3 remote scan operators in your query plan, and the actual join implementation happens on the head node that you're connected to. But we're also leveraging the information that you can give us about the partitioning that you're applying to these to the tables underneath, and that's basically this distribution information here that lives in the external table definition. And here I've chosen round robin, but you can also have a partitioned, a sharded distribution where the sharding or the partitioning happens over a particular column in your table. And if the partitioning is aligned between the different external tables that you define, that puts the query optimizer in a place where the joins can be pushed down into the individual databases. And then you have just a single remote scan operator that basically embeds the whole join query. The whole join query is shipped down to all of the databases, and the joins are being done locally completely, and only the results of the joins are being sent back to the head node. Yeah, great question. Would it ever redistribute data? At this point, it does not yet do that, but there is work in progress to allow basically sucking data from one place and then pushing it down into another database, which can give you great performance improvements. So we'll get there, not yet. Okay, so any other questions on the Elastic query? How do you guarantee that the schema is consistent across all of the databases? That's pretty much the responsibility of you managing the application. If it happens so that we cannot satisfy the external table schema from the underlying schema of the tables on the individual databases, we will let you know. So you'll see an exception show that tells you this. Okay, let's jump back. So this was Elastic Database Query. We announced it last week, and it will go into a preview by the end of this month, by the end of May. So it's not yet available today, but within the next few weeks, it will be available. If you're interested in that, please stop by after this session. I can let you know as soon as it is available, and then I can onboard you. Okay, so this was basically the challenge around how do I query across all of these databases that I need for my application. The next challenge then is manageability. I have all of these databases. My application goes through its normal life cycle. I may need to make schema changes to some of the tables over time. I have to create or rebuild indexes across these databases or update statistics, or just rotate my credentials on all of them. How do I do that? How do I make sure I don't forget any of the databases? And how do I get out of the business of basically looping and iterating over all of these individual databases? The way we would like this to obviously work is basically you give us a T-SQL script, and a magic capability takes care of rolling out that T-SQL script and running it across all of these databases. And this is what Elastic Database Jobs does for you. And as opposed to the Elastic Database Query, it's really targeted at scenarios where batch processing is appropriate. That's typically administrative operations. And the way that you define these jobs is by using T-SQL, and then you're submitting that piece of T-SQL into Elastic Database Jobs, and I'll show you in just a second how you can do that. And then behind the scenes, the jobs framework will take care of retrying the script against individual databases in the case of failure. And we have integrated it very tightly with Elastic Pools. Because it retries in the case of failures, one thing to keep in mind when writing and implementing these scripts is to make them idempotent so that they can be safely retried. So that's something to keep in mind. Let me show you a demo for this real quick. So here's a piece of T-SQL. And it addresses the problem that we currently only, oh, thank you. So back to Visual Studio. You have a piece of T-SQL that addresses the problem that our application right now only supports the United States. Bill is from the UK, so we want to support the UK. I'm from Germany, so let's start supporting these places as well. The way we do that is by just adding additional rows into the supported countries column in all of the different databases. Fun little example. So how do we now make sure that this happens on all of our databases? You go back into the portal, you go to the pool, and on the pool tab, you see these two buttons here. One is for creating jobs, the other is for managing existing jobs. Let's take a first look at this here. And there you can see a history of jobs that I have run before. The simple one you can look at, you can see this succeeded some time ago against the pool. Let's create a new one here. And let's call this demo insert. Oops, no. Let's paste our script here. And let's run this and see what happens. So looks like the job got submitted. Let's look into the running jobs. It's down here. And you can see it's currently processing across all of the databases. And this will update every 10 seconds and basically give you a status update on where the different jobs are. You can see the first ones are finishing. And in just a few seconds, that should be completed. And the tabs update differently, separately from each other. So this is already complete. Now we have the same over here. So in just the order of a couple of seconds, or let's say a minute or two, I was able to farm out that job across all of the databases that I have in the pool, which is really cool if you think about rebuilding indexes, maintenance operations like updating statistics. That becomes straightforward. And you can predefine these steps in here and just basically pick up one of the predefined scripts and just rerun it, and then it will get processed again. We are currently working on capabilities to also define schedules for that. So if you have maintenance operations that, for instance, need to run every weekend or so, you can schedule them once we have that capability lit up. I think there was a question somewhere back there. That's a great question. Right now, the endpoint that we provide you for doing this is through the portal. We are pondering about what else do we need. So what's the scenario where you would like to use that? Would you? Okay. Okay, good, yeah. All right. Yeah, we had lots of discussions, team internally, about that, and we thought, oh, we first need to have an easy and very approachable experience in the UI, but I hope that PowerShell is going to be next. All right, so that was Elastic Database Jobs. That brings us closer to the end of the session. We have a couple of minutes left. I want to use that to sum up. So Azure SQL DB All Up is a global database as a service capability in Azure. you can create databases in pretty much all the 19 data centers that we have across the globe. We have been focusing on predictable workloads, predictable performance and resource guarantees for databases over the past. Now we're also starting to support SaaS applications much better, in particular when they have less predictable workloads or massive scale in terms of the number of databases that they need to support. We hope that we make this a lot easier in terms of manageability through the Elastic Database pools that we talked about, through the Elastic Scale libraries that help you with managing all of these databases and doing the data-dependent routing between them. And then in addition to that, having Elastic Database Queries and Elastic Database Jobs, helping you with querying and managing your set of databases. I hope that we have a very comprehensive offering for you. If you are a SaaS provider, it should be much easier now, also from a development perspective. So with that, I'd like to encourage you to start building SaaS applications in Azure and on top of Azure SQL DB. And feel free to follow these links down here that take you to additional information about Elastic Database pools and the Elastic Scale and the Elastic Database tools as well. Okay. With that, this is the Azure sweepstakes slide that I've shown in all of the sessions that I did. And I know nothing about that. You all probably know more about it than I do. I think people are looking for a particular code on this. I'm not sure whether it's the session code that's down there, but try that. Other than that, and I'll leave this slide for the evaluation up here. Any other questions that I can answer?
So right now with pools, you only support standard, and I think the pricing is based off the pool capacity, right? But yet individual databases can only scale like to the top standard level. Have you thought about letting them scale, like individual database scale past that? You know, stay on the pool capacity, obviously.
So can individual databases scale beyond the pool, beyond the, let's say, the tiers limits? That's a great question. They cannot right now. So they're basically capped at whatever the, let's say, right now in the standard tier, whatever the max is, which is 100 DTUs for an S3. They're capped at that level. It's a great question. I'm not sure there is any limitation. We could probably let them spike up even further. The risk that you're running is that you're starving other databases that are living in the same pool. So you might get more exposure to noisy neighbor problems when you do that. But that's certainly an area where we can change things as we go. So as we see that customers are seeing that as a limitation, we can certainly look into removing that. Other questions? This one? Okay. Other questions? Non-sweepstake questions? Yes, please.
Can you answer a question about, I think last week there was an announcement on transparent data encryption in
That is correct.
Azure.
Yes.
When will that be available?
Great question. I don't know from the top of my head, but that should be available in, if not now, in the next couple of weeks. I've seen the emails go around where basically there was the sign off for it and everybody was happy. So that's rolling out right now. I saw Joachim, who's the PM in the back, but he's gone already. So he would know. He owns that area. I don't own that area. But if you want, just drop by after the session. Give me your email address, and I can find out for you. Other questions? So as of today, you can go to the Azure portal, and you'll find all of these capabilities that you saw, except for the Elastic Query part. This is the one. Give us 3 weeks for that to get opened up. if this is a big concern for you and blocking you, grab me after this session, and we can figure something out to get you access to it earlier than that. But we're kind of going through the last iterations of polishing it before we make it more publicly available. Yes, it is. That was one of kind of the code names that we used for it. Okay. All right. If there are no more questions, thank you very much for joining me that late in the afternoon. Hope this was useful, and good luck with Azure.